Yes, dear. Good morning, everyone.
Good morning, sir.
Good morning, sir.
Morning,
Good morning, sir.
morning Krishna, Raman, Prabjot. बहुत बिजी हो यार सुबह सुबह. चलो good. So आप seriously पढ़ाई का है. Yes, you have done lot of efforts. काफ़ी पढ़ाई की है आपने. So उसको सिर्फ याद रखना है. Keep it up to date. And एग्जाम का fear से नहीं जाना. No. First of all, get rid of that fear कि हाँ मैं एग्जाम को जा रहा हूँ. सिर्फ कॉन्फिडेंस रखना है कि yes, I will and I will do it. So we'll continue today with this gas carrier. I think we'll finish. So initially we have done the hazards, types. Normally questions if you see on the gas carriers, आपको hazards, reliquefaction plant, that how these vapors, how this boil off is reliquefied. Very simple it is, just a refrigeration. वो क्वेश्चन कॉमन रहता है. Types of gas carriers. You will see the tanks, but आपको tanks का नहीं है, but we call the containment system. इसके ऊपर आपके लिए ज़्यादा questions नहीं आते, but basically for hazards.
Good morning, sir.
Yeah, good morning, Divyansh. And we'll see a little bit of the procedure, how this loading is carried out, or what all preparations the ship has to do. So there are few things just for your knowledge that you should be aware कि gas carrier है क्या चीज़. Because they are specialized ships. Operation is slightly different as compared to your tankers. So mostly you are carrying liquid cargo. So there also in the tankers we carry liquid cargo. And I hope I had sent this checklist. All of you have received them.
Yes, sir. It's got checklist.
As you 2-3 भेजी थी, I think I have sent you the latest one as per the ISCOT 6th edition is there. So there are few changes, and that is a better one, that pre-arrival, then before commencement of cargo. So just go through this in case at any stage, even in orals, so you have an idea that what all operations, what all things to check. I know it's very difficult to remember all these steps verbally, no, not possible, but at least 15-20 steps or 10-15 steps. I think sometimes there's a question in written also, that at least 10-15 checks what will you do for the oil tankers. So there's not much of a difference, a lot of things are common. So थोड़ा सा उसको पढ़ लीजिए. चलो, we'll start with the today's topic. I think, yeah, how many of you are there? 23. Okay. Here we are up to what we see, the cargo containment systems, basically various types of tanks, pipelines. So cargo containment system है क्या? It's a total arrangement for containing cargo, including where fitted primary barrier, secondary barrier, associated thermal insulation, any intervening spaces, and adjacent structure for support of these elements. So this is what the cargo containment system is, that you are carrying these liquefied gases. So how we basically carry them, various type of ships we have seen, and let's see what these tanks are. Of course, little bit we will go, not so deep. For cargoes carried at temperatures between -10 -55, the ship's hull may act as a secondary barrier, and in such cases it may be a boundary of the hold space. So we have seen what is hold space, the space between your hull and the tanks. And basic cargo tank types utilized on board gas carriers are basically, if you see, first is independent tanks. So these independent tanks are completely self-supporting, do not form part of the ship's hull structure. As I told you, these tanks are made of special steels and they are just put inside the hull. Moreover, they do not contribute to the hull strength because it's like something you have put into the cargo hold. No, like we know containers, ठीक है, इनको fit कर दिया. Hull is a different thing. So depending on their design, pressure, there are 3 different types of tanks. So we have seen these gas carriers, fully pressurized, semi-pressurized, fully refrigerated. So accordingly, when they are fully pressurized means their tanks are designed accordingly, type A, type B, type C. So type A tanks constructed primarily of flat surfaces, maximum allowable tank design pressure in the vapor space 0.7, not high pressure. This means cargo must be carried in fully refrigerated condition. 0.7 bar is hardly any pressure. So, but the cargo is cryogenic, fully refrigerated, normally low temperatures -55, -60, and these tanks look like this. And very simple, in case question comes or somebody asks, I think not difficult to visualize. Tank is there, you got primary barrier, secondary barrier, the ship itself, the hull acts as secondary barrier. Secondary barrier means the cargo should not go up. And then you have the insulation in between. This is self-supporting prismatic tank which requires conventional internal stiffening, and tank is surrounded by a skin of foam insulation. In between there is a foam insulation where perlite insulation is used and found filling the whole of the hold space. So type A is again low pressure, thin tanks, but they can stand very low temperatures. Type B, again containment system is subject to much more detailed stress analysis as compared to type A. So what these controls are, basically they include investigation of fatigue life, crack propagation. So naturally the materials are tested to such an extent there should not be any, due to the low temperature, there should not be any cracks developing into this. Stress analysis are done, and they can withstand pressure up to again say 2 bar, so not very high pressure, so they won't be thick. Their construction again also not so thick steel, but they can stand, so they can be of spherical type of these types. Type C normally spherical or cylindrical pressure vessels having design pressure higher than 2 bar. Now if you see type A, type B, type C means type A very low pressure, very thin, type B slightly higher pressure, and type C more higher, more than 2 bars, and they are normally cylindrical. So type C tanks design and built to conventional pressure vessel codes, and as a result lot of stress analysis. Now they can be like this spherical, they can be bilobe type also, and like this, these are the bilobe. So this is again one of the tank systems. Another one, membrane tank. Now, membrane tanks means again the thickness of the membrane 0.7 to 1.5 mm thick only. So this is again a very specialized type of material used for this, to take care of all the stresses. And concept of membrane is based on a very thin primary barrier which is supported through insulation. Such tanks are not self-supporting like independent tanks, and an inner hull forms the load-bearing structure. Membrane system must always be provided with secondary barrier to ensure integrity of the total system in the event of primary barrier leakage. So these types, again there are basically 2 types membrane type of tanks. They were named after the companies who are making. Now both these companies are basically one, gas transport membrane system and This is again a very thin inward primary barrier, stainless steel alloy containing 36% nickel, carbon, again special metals because they are designed for very low temperatures, attached to the surface of again insulation. So there is a thick insulation because we are carrying low temperatures, no heat should pass, no heat should go inside, should not warm up the cargo. So here these type of membrane type of tanks, of course the internal construction is very different, but just for understanding, there's a lot of insulation, inner hull, outer hull, and again the space between the hull and these tanks. Technique is again similar company which makes these tanks, not much of a difference. Insulation is there, and again the spaces for your ballast tanks are enough. So this is ballasting. Ballast is again a totally separate system. Of course, even on tankers today we have segregated ballast tanks. Semi-membrane tanks again slightly different, made for different for LNG, where the temperature is -160. So you have a special type of tanks being made. Now integral tanks, again structural part of the ship's hull and influenced by same loads which stress the hull structure. Integral meaning itself is that these tanks form basically the part of the hull structure, and the car normally allowed for carriage of liquefied gas if the cargo temperature is below -10. Internal insulation, चलो ये तो आपके हो गए सारे tanks. Now comes your, on these ships there is lot of sensors, lot of high alarm systems, because there should be a, you cannot see that you are taking LNGs, it's a total enclosed system, but naturally there are high alarm and automatic shutdown systems are provided because of the safety. With the exception of type C tanks having capacity less than 200 cubic meters, every cargo tank must be fitted with independent high level sensor. Now these sensors are such that giving audible and visual alarms in your CCR. Float capacitance ultrasonic sensors may be used for this purpose. And high level alarm means it will automatically start shutting the cargo. The level means the tank is getting full, but that also can be dangerous. He suddenly shut the valve without the terminal knowing, so that also can create problems. So during cargo loading there is a danger of generating a significant surge pressure. You suddenly close the pressure. That's why we always say you also must be slowly learning that even on oil tankers, if you want, you have to inform the terminal before you shut down your last tank valve, because they are pumping cargo and you shut the valve suddenly, there can be a very big surge pressure which can damage the pipeline, anything. So इसके लिए this closing of the valves is done basically very slowly. The time factor is there so that there will be a lot of back pressure on the shore pump, and they come to know, so the pump also will trip, or they will come to know there is something going wrong. It's like you are discharging a cargo in the shore tank, people shut the valve. What will happen? You will find a lot of back pressure coming onto your pump, isn't it? And similarly, you may have high pressure trip, or if you are watching, you may stop the pump, so you come to know that there is some obstruction, somebody has closed the valve. So same way here you have the especially alarms, and closing of these valves is again done as per the timings, that they do not immediately, there should not be a sudden shutting of the valves. It should not create a surge pressure. Now carrier ports, of course we have seen the gases are carried from long time, and as soon as the ships come out, so IMO, the body, whosoever that time was there, so they start thinking about the safety. So these gas carrier codes, basically any codes, they give you the entire information about the construction, equipment, procedures, what all to be followed. So purpose of these codes is to provide international standard for safe transport, and it is done by prescribing design, construction standards of the gas carriers and equipment they should carry, so as to minimize the risk. That is the whole idea. Now after a lot of research was done that how these gases can be carried, now we have seen that instead of carrying them in a gaseous state, these gases are converted to the liquid, and then these liquid gases are carried in tanks. So hazards in gas cargoes may arise owing to the products being transported under cryogenic or pressure conditions. Now we have seen basically the gases are carried in basically two states, either they are under high pressure or they are under low temperatures, isn't it? So इन्हीं के लिए the first thing it comes is if some mishap takes place, any collision stranding could lead to cargo tank damage and uncontrolled release of the product that is dangerous. So the construction is such that as far as possible they try to save that the cargo should not come out, whatever happens. So that's why these tanks are constructed in such a way away from the hull that something happens. So anyway, so we try to be safe, but nobody does intentionally. Anytime anything can take place due to bad weather or due to anything. So such release could result in evaporation, dispersion of the product, and in some cases could cause brittle fracture of the ship's hull. The cargo is gone out, finished. So therefore the requirements in these codes are intended to minimize these risks as far as is practicable based upon the present knowledge and technology. So that's why these codes, they keep getting updated, amendments keep coming, new technology, new research, new products, and new ways of handling. So layout of this code is in line with the basically international code for construction equipment, what we call the IBC code, similar like what we have for the chemicals, but few changes in the tank construction, tank materials. So overall layout of gas carrier similar to that of construction of oil tanker from which it is basically evolved. And cargo containment system and its incorporation, however, very different due to need to carry cargo whether under pressurized system or refrigerated conditions. So there the tank system will vary. So that we have seen. Now these codes basically, if you see, they apply to all the gas carriers regardless of the size. And first was the gas carriers built after June 86, so IGC code. So code which applies to new gas carriers built after 86 is the international code for the construction and equipment of ships carrying liquefied gases. So after 86 means, of course, these ships are also becoming like old ships now. So in brief, the code is known as IGC, mandatory for all as per SOLAS, and as a proof, now the ship complies with the code. So you have the certificate here. In this case, we call it International Certificate of Fitness for Carriage of Liquefied Gases. So this certificate, of course, will be issued after the ship undergoes a total examination survey, and they find that everything is as per the code, whatever is mentioned, whatever conditions, whatever systems to be fitted, and then you get. So by looking at this, that you have been granted this International Certificate for Fitness of Carriage of Liquefied Gases, so we know the ship complies with the code. Now, gas carriers built between 76-86, so they were the old ships again. So these were again like covered under what we call the GC code. So gas carrier, abhi the IGC code, that was those days it is called GC code. So वहाँ पे भी आपको कि whether the ship is complying with GC or IGC, so there the आपकी जो certificate of fitness है that will be slightly different. And gas carriers built before 76 existing ships, they are covered again code for existing ships. So its content is similar to GC code. So of course you should be bothered about the new ships, not the old code what is given in the new code. So that is what we are going to see. You should be aware of it, that these are the basically codes which are applicable, and accordingly the certificate of fitness is issued. अब certificate of fitness क्या चीज़ है? It is also similar to like we have been seeing these other ships like IMDG. We have document of compliance. So that certificate also basically we have seen, it gives you what all things are to be there on the ship, what all things are fitted, can the ship safely carry these cargoes, and then the document of compliance is, in case of grain, we have seen there also the document of authorization. We call it DOA. So here they call it certificate of fitness. So you can make out, yes, certificate of fitness for this gas chemical carriers. So इनका भी purpose क्या है? Certificate of fitness again same survey. Ship complying with an older IMO gas code should be surveyed, issued with a certificate of fitness. वहाँ पे इसको कहेंगे सिर्फ certificate of fitness for carriage of liquefied gases. That means it is complying with the existing ships GC code, and it remains valid dependent on the results of intervening surveys for a period of 5 years, assuming ship has not changed flag. And where the ship is designed in accordance with the new code, if the ship is built after 86, then certificate is called International Certificate of Fitness for carriage of this thing. Otherwise it's called Certificate of Fitness for carriage. Now the word international, that shows that it is complying with IGC. If it is Certificate of Fitness, that means it is complying with GC. And such certificates basically signify a minimum standard of constructional safety has been achieved and list of cargoes which the ship is certified to carry. So of course by the time you become chief officer, so इससे पहले भी ठीक है, knowledge only is not a bad thing, that whenever you go back on the ship, if you are working on gas carriers, so no harm in having a look here what all cargoes it is certified to carry. Of course a lot of people are there to check, nobody will offer the cargo which the ship is not certified to carry, but also knowledge तो होनी चाहिए. So जितनी जल्दी आप इसको देखोगे, जितनी जल्दी you start seeing these things, so by the time you become chief officer you are very thorough. यहाँ यार ये document कहाँ पे होता है, इसके अंदर क्या दिया होता है, what all things are given, what all I have to check, and what all you need to inform company कि भाई this is the requirement, this needs to be installed. अब आपका आ गया कार्गो इक्विपमेंट इंस्ट्रूमेंटेशन कि चलो कोड्स तो हमने देख लिए. सो not like other tankers, so here you also have deep well pumps or submersible pumps. So there are basically two types. Basically most of the ships equipped with deep well pumps. Now deep well pumps are most common type, like what we call Fremo pumps, and the pump is operated electrically or hydraulically by a motor which is flange mounted outside the tank. So it's like again a deep long shaft, and the pump is there and the motor is on top. The drive shaft is guided carbon bearings inside the discharge tube, and these bearings are in turn lubricated and cooled by the cargo flow up the discharge. So this is again, so thoda sa aapko, I don't know, the guys who have been working on at least product carriers, so they may have seen this. Chemical carriers, you must have seen these pumps. So here it is basically a 3-stage pumps are there. So they are impeller 1, 2nd, 3rd, and inducer just to collect the cargo, and then this cargo is basically pumped and you have the motor on deck. The motor is outside. It can be electrically driven or it can be hydraulically. Normally they are hydraulically. Big hydraulic power pack is there, so which runs this pumps. So individual tanks, individual pumps like chemical carriers. Impeller assembly is mounted on the bottom of the cargo tank and will frequently comprise 2 or 3 impeller stages. And together with first stage inducer, that is basically to collect the cargo, and this later is an axial flow impeller used to minimize the NPSH requirements. Of course, this to give you again shaft sealing arrangement consists of double mechanical seal, so no need to go in detail. Second type is your submerged pumps. Now submerged pumps are basically like how they look like. If you see this, so they are inside the tanks. The whole thing is inside the your cargo tank. So here this type of pump is used on LNG carriers on many of the larger fully refrigerated carriers. Pump assembly, electric motor closed, coupled and installed in the bottom of the cargo tank. And power is supplied to the pump motor through copper or stainless steel sheeted cables which pass through a gas tight seal in the tank dome and terminate in the flame proof junction box. So of course you can see the technology. Yet all these completely sealed and closed pumps are situated inside this, and submerged pumps and their motors are cooled and lubricated by cargo. So this is how basically they look. So anytime if any question is asked, so yes, you know what type of system is there for discharging the cargo. Loading, of course, is directed to the pipelines. So discharging time, we are going to use these pumps. Now another thing where the question is common is the reliquefaction plants and boil off control. Now ये थोड़ा सा important है and simple. There is nothing to worry कि यार मैंने chemical tanker पे काम नहीं किया, I don't know. But whereas the theory is concerned, it is easy. So with the exception of fully pressurized gas carriers, means must be provided to control cargo vapor pressure in cargo tanks. Now, why they are saying exception to fully pressurized? Because the ships which are fully pressurized, their construction is different. They can stand high pressure. Whereas if you see the ships which are carrying cargoes at very low temperature, their tanks are capable of withstanding low temperatures but not very high pressure because the thickness of the tank is small. Now if in these tanks which are carrying refrigerated cargoes, cryogenic cargoes, now if there is in these tanks, if the pressure goes up, what will happen? There is a danger of damage to the tank, isn't it? And how this pressure will go up? Now you have liquefied the gas to say LNG is minus 160 or other gas say 100 degrees, 110 degrees minus, and slight change in temperature, slight transfer of heat. So this temperature, the gas temperature comes up, it will boil off, isn't it? It will immediately get converted to the vapors. So slowly these vapors start generating and they will start collecting in the vapor space and we start increasing the pressure in the tank. So अब इस pressure को हम कैसे control करें? So there is only one thing. Yes, we say that first thing we let not vaporize the cargo. या तो cargo vaporize ना हो, so that is difficult. कुछ ना कुछ थोड़ा सा cargo is moving, चाहे sloshing or by a little bit of change in temperature, the vapor generation is possible. And second, ये जो vapors हैं, इनको हम वापस we convert these vapors back to the liquid. So this process of converting these vapors, what we call the boil off, which is taking place inside the tank, if we can take these vapors, suck these vapors, compressor में डालो, like a refrigeration system. Of course, they are big. Reliquefaction plants are a bigger thing. So we take these vapors out, compress them, cool them, convert them back into liquid and put it back into the tank. So at least your tanks do not get pressurized. So this is basically a reliquefaction plant. So in case of LPG chemical gas carrier, a reliquefaction plant is fitted for this purpose. Especially this plant will be fitted on the ships which are carrying cargoes at low temperature, isn't it? For high pressurized vessels, no. Because there we are not converting the gas by lowering the temperature. There the gas is converted by high pressures. So equipment is designed to perform basically to cool down the cargo tanks and associated pipeline before loading. So ये जो plant है, this is used for two purposes. One, initially for cooling down also. या भी आपके normal tanks है, just imagine, you can visualize that you have the tanks at normal temperature. When you put this cargo, liquefied gas, tank temperature is normal temperature, it will immediately vaporize, isn't it? तो -100 पे है, अगर उस liquid को मैं एक normal tank के temperature पे डालता हूँ, which is at 20-30 degree plus, so this liquid will immediately vaporize and it will again convert back into the vapors and again pressure will increase. So even that time उसके vapors को we take out, convert them back into liquid. Pipeline है, किसी को भी ठंडा करना, converting them back into the liquid. So one purpose is that. Second, to reliquefy the cargo vapor generated by flash evaporation. इसे हम boil off कहते हैं. Liquid displacement and boil off during loading. And third, to maintain cargo temperature and pressure within prescribed limits while during passage. and by reliquefying the boil of vapor back into the liquids. So इस plant का ये purpose है. So basically ये plant आपका होगा on the ships which are carrying low temperature gases, but not for the LNG carriers. LNG is basically, you know, it's methane. The LNG में क्या problem? There the temperature is very low, -160. To convert this vapors, this gas back to liquid, you have to cool down this gas to -160. So उसके लिए you need a very bigger plant, which is not possible on the ship. Sure, yes. So that's why for these LNG carriers it is different. So they don't convert these vapors to liquid. Instead, they use these vapors for engine. So that's the basic difference. Now, what are the types of these plants? What all is available? There are basically two main types of this reliquefaction plant: direct cycles, where the evaporated or displaced cargo vapor is compressed, condensed, and returned to the tank. So this is most commonly used type, but may not be employed for certain gases. Indirect cycle, where the external refrigeration system is employed to condense the cargo vapor without it being compressed. आप इसके लिए आपने एक external दूसरा refrigeration system है जो उसको इन वेपर्स को ठंडा करेगा. So this cycle is relatively uncommon. So पहले वाला direct cycle is more common, which is normally there, that you suck these vapors out of the tank, compress them, and then cool them in a condenser, and then through the expansion valve it expands, lowers the temperature, gets converted into the liquid and goes back to the tank. So उसके लिए they say there are three main types of direct cycle. One is single stage direct cycle or single stage direct cycle. I think anybody can make this sketch. This is a tank and vapors from the cargo tank. Here the vapor generation is there. ये आपका liquid gas है. In case there is a vapor generation, so they take these vapors, put it into the compressor. Now these are all special equipment, not like normal compressors. So of course all precautions, all recommendations, very safe. So when you compress these vapors, naturally temperature goes up. Volume will decrease, but the temperature of this compressed gas will go up, and then it is cooled in a condenser. Condenser क्या? Where the seawater cooling is there, and this compressed gas, which is at high temperature, it is cooled. So the moment it is cooled, it gets converted into the liquid. So this partially liquid or gas is passed through the expansion valve. Immediately temperature is lowered and it is again getting totally converted back to the liquid. Then it can be sprayed either through this, or it can be put inside the tank through another pipeline. तो स्प्रे करोगे तो फिर वेपराइजेशन हो. So it depends. So basically this is a system to convert these vapors back so that no high pressure develops in the vapor space of the cargo tank where you are carrying this cargo. Three main types of direct cycle. Now one is single stage. So आपको question आता है what is reliquefaction plant and how many types, and describe any one of them. So no need to describe all, one is enough. Single stage आपने देख लिया, single stage direct cycle, and here where the suction pressures are relatively high as in carriage of semi-refrigerated products, then this cycle is suitable. Boil off vapors from the cargo tank are drawn off by the compressor and compressed. The compression process increases the pressure and temperature of the vapor, allowing it to be condensed against seawater in the condenser, and this condensed liquid is then flashed back to the tank via float controlled expansion valve. So this is basically like a refrigeration system. या आपने vapors को ठंडा किया, converted back to the liquid and put it back into the tank. So the returned liquid vapor mixture to the cargo tank may either be distributed by a spray rail at the top of the cargo tank or taken to the bottom of the tank to discourage re-vaporization. It's like you're loading a liquid, so we don't throw the liquid from top into the tank, isn't it? There is a possibility आधा तो है spray में हो जाएगा. Like tankers you are loading, You put these top lines are connected through the drop lines with the bottom lines, so the liquid is not splashed. So it is just put inside the tank through the pipeline. So same way here, system must be fitted on the tanks, that how this liquid has to go back into the tank. Two-stage direct cycle, so that was single stage. Two-stage may, yes, sometimes the cooling is not that effective. The high temperatures from the compressor, the vapors are compressed at very high temperature, so you need a multi-stage of cooling. So two-stage cycle with interstage cooling is used, where suction pressures are low and as a result compression ratios are high compared to the single stage. So here if you see, now here tank, these vapors are drawn, stage 1 compressor, and this is again put back to an intercooler in between, intermediate cooler like, so which is also cooled by part of this cargo, not by seawater, cooled by the partly by the cargo. So here also it is like a normal condenser ki jagah we have an intercooler, and then same story, and then this cooled cargo on lower temperature again goes to second stage compressor. So here again, here it is cooled by seawater and then finally sent back to the tank. So this is again a two-stage, what we call direct liquefaction cycle with interstage cooling. This is an interstage or intercooler, what we call. Here may be a high temperature developing which may not get cooled by a single stage condenser, so you partly cool it here, then again compressed and then cool it and send it back. Two-stage compression with cooling between the stages is therefore sometimes necessary to limit compression discharge temperatures, which increases significantly with the increasing compression ratios. So vapor from the first stage discharge is taken to an intercooler where its superheat is removed and the cooling medium is cargo liquid flashed down to the intercooler pressure from the seawater cooled condenser, and remaining parts of the cycle similar to the single stage. And third इसमें indirect cycle वालों में the direct cycle जो है आपकी direct stage है cascade direct cycle. This is again a long process, again certain shifts again as per the requirement. In this case, system uses a refrigerant such as R22 Freon to condense cargo vapors instead of like a seawater cooling. So in this case, if you see, again cargo vapors, compressor. Now here, this is a condenser which is cooled by this refrigeration system. So this is another refrigerant which is basically this cycle is running. This is getting cooled here by seawater, and ये जो refrigerant है, this is cooling this compressor, this condenser. So this is additional system. Of course, some ships where the requirement is there. So this is what is called the cascade system. It is a totally independent another system which is cooling this condenser instead of cooling it by seawater or intercooler के साथ. Naturally, here the cooling will be more effective and then goes back as a liquid into the tank. So cascade वाले में ये system है आपका. So किसी एक का भी आप diagram बना के you can see. अब आपका आ जाता है कार्गो ऑपरेशंस. थोड़ा सा none of you have said, so at least we should have an idea. At least एग्जाम में they can ask you क्या है, गैस कैरियर है, इसका क्या प्रोसीजर. So assuming a gas carrier comes directly from shipyard or dry dock, the general sequence of the cargo handling operation आपका क्या क्या होगा. Now जैसे हमने देखा है compared to the tanker. Now if the tanker is coming from a dry dock or a newly built ship, उसमें क्या करते हैं, टैंकर में क्या करते हैं, हाउ डू वी लोड द शिप. एनीबडी जिन्होंने टैंकर्स पे काम किया. इफ न्यू टैंकर इज कमिंग फ्रॉम ड्राई डॉक और फ्रॉम न्यू बिल्डिंग, कैन वी लोड डायरेक्टली ऑयल इनटू द टैंक्स. कि ब्रांड न्यू टैंकर है तो कैसे करेंगे. एनीबडी चलो यार कोई तो बोलो। क्या कहते हैं, किस किसने किए टैंकर्स? व्हाट यू कैन इमेजिन, सपोज ड्राई डॉक में कहते हैं यार बड़ा अच्छा है, 1 महीने की ड्राई डॉक, 1 महीना तो ऑफकोर्स नाउअडेज नहीं होता, सो 15-20 डेज आपने ड्राई डॉकिंग में काम भी किया, सारी टैंकर की रिपेयर्स की, सब साफ सफाई भी थी, अब हम लोडिंग के लिए आए हैं, इजंट इट? सो क्या आता है आपके मन में? सो दिस इज अगेन विच इज सिंपल क्वेश्चन दे विल बी आस्क्ड टू यू कि ओके व्हेन यू कम आउट फ्रॉम द ड्राई डॉक और अ न्यू बिल्डिंग, how will you load, what all precautions or what all things will you carry out? ऑयल टैंकर की बात कर रहा हूँ, क्रूड ऑयल कैरियर नॉर्मली से एनी, चलो चाहे क्रूड हो चाहे प्रोडक्ट हो, सेम थिंग। अभी तो बहुत डिटेल में पढ़ लिया है। बताओ बताओ, कोई तो बताओ, टैंकर वाला। नो, क्या कहते हैं आप? तो शर्माते हो तो कैसे, हाउ विल यू आंसर द सर्वेस? उनके सामने तो आपने टाई सूट बूट पहन के बैठे होगे, तब भी आपको बोलना है, तो कैसे बताओ? ऐसा तो हो नहीं सकता कि किसी को भी ना आता हो, दैट इज नॉट पॉसिबल। टैंकर वाले कौन कौन है? कृष्णा, यू हैव डन टैंकर?
यस सर।
कौन से किए टैंकर, क्रूड किया प्रोडक्ट की?
मैंने प्रोडक्ट किया।
प्रोडक्ट कैरियर, सपोज आप एकदम से नया प्रोडक्ट कैरियर लेके आ रहे हो, तो क्या करोगे सबसे पहले? विल यू लोड डायरेक्टली, चलो टर्मिनल पे आए, ऑल फास्ट किया, नहीं लाइन सेटअप की और स्टार्ट लोडिंग? क्या कहते हैं, क्या आता है आपके मन में? बाकी शिप्स में तो है ठीक है, बल्क कैरियर कंटेनर वाले तो ठीक है जी, स्टेशंस ऑल फास्ट, चलो ओपन द हैच कवर्स एंड दे स्टार्ट लोडिंग, नो?
स्टार्टिंग में स्लो लोडिंग करते हैं, उसके बाद स्टार्टिंग में स्लो लोडिंग करते हैं, उसके बाद स्पीड इंक्रीज करते हैं सर।
ठीक है, चलो आप कह रहे हो स्टार्टिंग विल डू स्लोली, तो स्टार्टिंग से पहले, सबसे पहले अगर आपका टैंकर है
करना है।
या आपके टैंक्स में तो एटमॉस्फेयर है, 21% ऑक्सीजन है पूरी।
यस हाइजीन है फर्स्ट हाइजीन है।
यस, आने से पहले, बिफोर इवन यू अराइव एट टर्मिनल, टर्मिनल विल नॉट अलाउ यू टू बर्थ। ये तो है नहीं कि आप चुपचाप से अपना जहाज लेके कार की तरह या ट्रक की तरह अपनी गाड़ी पार्क कर दो, नो?
5% से लेस आईजी होनी चाहिए।
यस, तो आईजी नहीं, आपको व्हाट वी कॉल इज द टैंक्स मस्ट बी इनर्टेड, isn't it? So you have to carry out the inerting. So आपको सिंपल कोई भी क्वेश्चन पूछे, so yes you should be able to answer कि sir yes, before the tanker comes for the loading port or for the loading terminal, before we arrive the ship has to be in inert condition, not only near the terminal. The moment she comes out of the dry dock, जैसे सब काम खत्म हुआ तो उसकी ठीक है, ड्राई डॉक से निकलने से पहले आप सबने इंस्पेक्शन की, every ship when she comes out of the dry dock complete होती है, so we carry out the inspection, isn't it? क्या यार सब कुछ ठीक है, ट्रायल्स भी करते हैं क्या जो सिस्टम उन्होंने कहीं रिपेयर किया कुछ है, चलता भी है कि नहीं चलता भी। तो वो सारा काम होने के बाद immediately before you start sailing you inert the tanks, even at sea. At no time the tank atmosphere should be in the flammable range. That is the idea, that was the idea of studying that flammability diagram. ठीक है, ड्राई डॉक में काम चल रहा है वहाँ पे ठीक है, वहाँ पे ऑफ कोर्स इनर्टिंग नहीं है, वहाँ पे आपको मैन एंट्री चाहिए, तो वहाँ पे टैंक्स आर टोटली गैस फ्री। बट उसके बाद व्हेन यू आर सेलिंग, द मोमेंट यू कम आउट ऑफ ड्राई डॉक, सो वी स्टार्ट इनर्टिंग एट एनी स्टेज एट एनी टाइम, जब हमें टैंक्स के अंदर नहीं जाना, कुछ नहीं करना, लोडिंग के लिए तैयारी है, एंड वी फर्स्ट थिंग इज इनर्ट, ताकि ऑक्सीजन जो है वी ब्रिंग इट डाउन लेस देन 8%। इन गैस कैरियर्स में अगेन यहाँ पे तो सिर्फ इनर्टिंग से तो बात चलेगी नहीं। यू कैन जस्ट इमेजिन, जस्ट विजुअलाइज कि आप टैंकर पे आ रहे हो एंड नाउ यू आर गोइंग टू लोड कार्गो एट से -100 डिग्री सेंटीग्रेड। अब आपके मन में कि अच्छा जी मैंने इनर्टिंग कर दी, तो इनर्टिंग से भी थोड़ा सा तो हैजर्ड्स हमने पढ़े, इज़न्ट इट, यार गैस कैरियर के साथ क्या क्या हैजर्ड्स हैं। तो उन्हीं को अगर आपको थोड़ा सा ध्यान से पार्टिसिपेट कीजिए, सुनिए, सो आई डोंट थिंक आधी चीज़ें तो वैसे ही आपके माइंड में चली जाएंगी। प्रेपरेशन फॉर लोडिंग, टैंक इंस्पेक्शन फर्स्ट थिंग, before any cargo operations are carried out, essential cargo tanks are thoroughly inspected for cleanliness. वो हम कर देंगे ड्राई डॉक निकलने से पहले, and all loose objects removed, all fittings, everything is properly secured. तो ये इंस्पेक्शन तो आपकी ड्राई डॉक से निकलने से पहले ही कंप्लीट होगी। इन एडिशन एनी फ्री वाटर मस्ट बी रिमूव्ड, सो टैंक्स को अंदर सब सफाई करके देयर शुड बी नो वाटर, बिकॉज हमने देखा अब मैं ठंडा कार्गो लोड करूंगा तो जो अंदर पानी है वो भी आइस बन जाएगा, एंड आइस बना व्हाट वी कॉल इज अ हाइड्रेट फॉर्मेशन, तो डेंजरस है पंप्स के लिए। एंड वंस दिस इंस्पेक्शन हैज बीन कंप्लीटेड, द कार्गो टैंक शुड बी सिक्योरली क्लोज्ड, एयर ड्राइंग ऑपरेशन स्टार्ट। उसको सबसे पहले आपने ड्राइंग करना है। तो ड्राइंग द कार्गो हैंडलिंग सिस्टम इन एनी रेफ्रिजरेटेड शिप इज नेसेसरी प्रायर टू लोडिंग। क्यों कि अगर उसके अंदर वो ड्राई ना हुआ तो वेपर्स हुए, वाटर वेपर्स हुए या पानी हुआ, तो जैसे हम उसको कूल करेंगे तो सारा आइस बन जाएगा। एंड हम कैसे पंप्स को यूज़ करेंगे? सो दिस मीन्स द वाटर वेपर एंड फ्री वाटर मस्ट ऑल बी रिमूव्ड फ्रॉम द सिस्टम, एंड इफ दिस इज नॉट डन द रेजिडुअल मॉइस्चर कैन कॉज प्रॉब्लम विद आइसिंग एंड हाइड्रेट फॉर्मेशन विद इन द कार्गो सिस्टम। क्लीनिंग होगी, उसके बाद आपकी ड्राइंग। द टैंक एटमॉस्फेयर ड्राइंग कैन बी अकम्प्लिश्ड इन सेवरल वेज, ड्राइंग यूजिंग इनर्ट गैस फ्रॉम द शोर, ड्राइंग यूजिंग इनर्ट गैस फ्रॉम द शिप्स प्लांट, और ऑन बोर्ड एयर ड्राइंग सिस्टम अगर कुछ है आपके पास। ना आफ्टर द ड्राइंग, सो आपने वो ठीक है सारा का सारा जो भी है वाटर वेपर कुछ भी था सब टोटली ड्राई गैस आपने डाल दी। नाउ कम्स इनर्टिंग बिफोर लोडिंग। नाउ इनर्टिंग कार्गो टैंक्स, कार्गो मशीनरी, पाइपलाइंस इज अंडरटेकन प्राइमरी टू एंश्योर नॉन फ्लेमेबल कंडीशन ड्यूरिंग सब्सिक्वेंट गैसिंग अप विद कार्गो। सो उसके बाद आपने जब देख लिया कि आपका टैंक क्लीन है, ड्राइड है, एंड देन वी डू द इनर्टिंग। इनर्टिंग का पर्पस क्या है? टू ब्रिंग द ऑक्सीजन कंसंट्रेशन बिलो 21, isn't it? 8% पे 5 to 6%, मैक्सिमम 5% बाय वॉल्यूम। अब आपने जब इसकी इनर्टिंग कर दी, अब आपके टैंक्स में ठीक है ऑक्सीजन तो आपने रिमूव कर दी। नाउ सेकेंड स्टेप कम्स इज द गैसिंग अप। व्हाट इज गैसिंग अप? अब आपके जो इनर्ट गैस है, जो आपने टैंक में इनर्ट गैस डाली है, उसमें नाइट्रोजन भी, कार्बन डाइऑक्साइड भी, दैट इज अ मेन कंस्टिट्यूएंट इनर्ट गैस में, isn't it? हमने देखा कंस्टिट्यूएंट्स ऑफ इनर्ट गैस मैक्सिमम इज नाइट्रोजन एंड देन कार्बन डाइऑक्साइड। अब ये जो दोनों गैसेस हैं, इनको आप कंडेंस नहीं कर सकते रीलिक्विफिकेशन प्लांट में, इनकी प्रॉपर्टीज अलग है, इनको लिक्विफाई नहीं किया जा सकता। तो ये तो गैस स्टेट में ही है, हवा में प्रॉब्लम आएगी, बिकॉज हमने तो कार्गो एकदम से ठंडा लोड करना, उसके जो वेपर्स बनेंगे उसको हमने रीलिक्विफाई करना है। अब वेपर्स के साथ तो नाइट्रोजन मिक्स हो गई, तो आपके लिए आपका जो प्लांट है, जो रीलिक्विफिकेशन प्लांट हम पढ़ रहे थे, वो फेल हो जाएगा, वो तो इसको लिक्विफाई कर ही नहीं सके। सो दिस इज बिकॉज द कार्गो टेम्परेचर्स ईच इज अबव इट्स क्रिटिकल टेम्परेचर एंड देयरफॉर इनकंडेंसेबल। अब इसको भी निकालना पड़ेगा टैंक में से, नाइट्रोजन कार्बन डाइऑक्साइड दोनों को जो भी कंडेंस नहीं कर सकते, so we have to take it out of the tank. So accordingly, removal of this inert gas from the cargo tank is necessary. तो अब हम क्या करेंगे? सो दिस इज अचीव्ड बाय व्हाट वी कॉल गैसिंग अप। सो ये भी कभी आपको क्वेश्चन पूछा जाता है, व्हाट इज गैसिंग अप ऑन अ गैस कैरियर। कि गैसिंग अप इज बेसिकली आपने उसको टैंक को इनिशियली आए थे, सफाई इंस्पेक्शन की, सब साफ़ किया, उसके बाद आपने उसकी ड्राइंग की उसकी, एंड देन इनर्टिंग की। इनर्टिंग के बाद हम उसको गैस अप करते हैं टू रिमूव दिस nitrogen carbon dioxide which is there in the inert gas. Why? Because they cannot be condensed. And using how this is achieved by gassing up, using vapor from the cargo to be loaded at ambient temperature and venting the these inert gas जो है to the atmosphere. अब हम क्या करते थे, जैसे आप inerting में क्या कर रहे हैं, we put the IG, isn't it, into the tank, and IG क्या करती है, जो आपका अंदर एटमॉस्फेयर है, जो नॉर्मल एयर है अंदर आपकी एटमॉस्फेयर की, जिसमें 21% ऑक्सीजन है, उसको पुश करके बाहर निकाल देते हैं, isn't it? And slowly you find all the air is displaced by the IG which we are injecting into the cargo tanks. अब यहाँ पे आप जो लिक्विड, अपने जो लिक्विफाइड गैस यूज़ करनी है, लोड करनी है, आप उस लिक्विफाइड गैस को डालोगे, इमीडिएटली वेपराइज हो जाएगी, बिकॉज अंदर टेम्परेचर तो ज़्यादा। सो बेसिकली यू आर इंजेक्टिंग दोज वेपर्स जिस कार्गो को आपने लोड करना है। सो वो वेपर क्या करेंगे, इस इनर्ट गैस को निकालना शुरू कर दें। सो यू ओपन द वेंट्स एंड वहाँ से आप आपकी जो IG आपने डाली थी उसको आप रिप्लेस करना शुरू कर दो बाय द कार्गो वेपर्स, यूजिंग वेपर्स फ्रॉम द कार्गो टू बी लोडेड एट एम्बिएंट टेम्परेचर। क्यों कि जैसे मैंने कार्गो लोड किया वो लिक्विड में आ रहा है, बट जैसे उसने आपकी पाइपलाइन, गर्म पाइपलाइन या टैंक को टच किया, वो गैस बन जाएगी। स्लोली यू विल फाइंड कि ये सारी की सारी जो अंदर आपकी इनर्ट गैस है, IG है, वो सब डिस्प्लेस हो जाएगी बाय द कार्गो वेपर। तो ये आपकी दिस इज बेसिकली व्हाट वी कॉल द गैसिंग अप। अब आपने IG निकाल रही है, नेक्स्ट आ जाता है अब आपको टैंक को ठंडा करना। क्यों? आई कैनॉट लोड सच लो टेम्परेचर कार्गो इन एम्बिएंट टेम्परेचर पे जो आपका टैंक्स है, थर्मोस्टेसिस। इमीडिएटली किसी चीज़ को भी आप, हमने पढ़ा भी है, isn't it, ब्रिटल फ्रैक्चर, सडनली टैंक नॉर्मल टेम्परेचर पे, उस पर आप -100 का कार्गो लोड कर दो, बस तो गैस बन जाएगा, बट टेम्परेचर तो नीचे आएगा, सो इट कैन डेवलप एनीथिंग। तो इसलिए टैंक्स को स्लोली कूल डाउन करना पड़ता है। तो आपने पहले क्लीनिंग कर दी, ड्राइंग कर दी, इनर्टिंग कर दी, फिर गैसिंग अप कर दी, अब कूलिंग डाउन। Cooling down consists of spraying cargo liquid into a tank at a slow rate. The lower the cargo carries temperature, the more important to cool down the procedure becomes. Now, before loading a refrigerated cargo, the ship's tanks must be cooled down slowly in order to minimize the thermostasis. किसी भी चीज़ को immediately suddenly heat नहीं करते, आपने इंजन को भी देखा होगा। So when you ask the engineers, when you give them 2 hours notice, so what they do, why they need 2 hours notice? Because they preheat the engine. अब इंजन बंद था, ठंडा था। सिंपल एग्जांपल, कार, आपकी डीजल ऑपरेटेड कार है, सर्दियों के मौसम में अगर इंजन बंद है तो यू डोंट इमीडिएटली स्टार्ट ड्राइविंग, इजंट इट? हम उसे थोड़ी देर स्टार्ट करके रखते हैं, दैट इज बेसिकली प्री हीटिंग द इंजन। सेम थिंग इज यहाँ पे प्री कूलिंग इज रिक्वायर्ड। वहाँ तो था कि यार प्री हीटिंग से पहले आपको उसको प्री हीट करना है, यहाँ पे कूलिंग से पहले प्री कूल करना है। So before loading this cargo, ship's tanks must be cooled down slowly in order to minimize thermostasis. And the rate at which a cargo tank can be cooled without creating high thermostasis depends on the design of the containment system and is typically about 10 degree centigrade per hour. Now imagine your tanks are at even say 20, 25 degree or 30 degree plus, और आपको उसको 100 डिग्री माइनस पे लेके आना है, कितने घंटे लग जाएंगे? Isn't it? So ship is ideal just cooling. तो ये तो फर्स्ट टाइम तो एक प्रोसीजर तो करना ही पड़ेगा, एक बार तो आपको 18-20 घंटे शिप जो है वो एटलीस्ट 14-16 आवर्स तो किनारा रहेगा ही रहेगा कूलिंग डाउन के लिए। So today, though, of course, time is money. Nobody can allow that. So reference should always be made to the ship's operating manual to determine allowable cool down rate. कि किस रेट से उसको कूल करना है, तो सारा का सारा आपके मैनुअल में लिखा होगा. And cargo liquid from shore or from deck storage is gradually introduced into the tanks, either through the spray lines if fitted for this purpose or via the cargo loading lines. So the vapors produced by this, जैसे ही आप ठंडा कार्गो इंट्रोड्यूस करोगे, लिक्विड गैस इंट्रोड्यूस करोगे, तो इवेपोराइज हो जाएगी. सो रैपिड इवेपोरेशन विल बी टेकन ashore और हैंडल्ड इन द शिप्स रीलिक्विडेशन प्लांट. जैसे ही वेपोराइजेशन हुई, उसने ठंडा तो करना शुरू कर देगी, बट वेपर्स बनेगा, उसको भी हमें हैंडल करना है. अब उन वेपर्स को हम वापस या तो किनारा भेज देते हैं या फिर अपने शिप के रीलिक्विफेक्शन प्लांट में वापस उसको भी लिक्विड में कन्वर्ट करते हैं. So additional liquid is then introduced at rate depending upon the tank pressure and temperature. So this is basically a procedure. Cool down should continue until, अब क्या होगा, आस्ते आस्ते आप कूलिंग डाउन कर रहे हो, आपने लिक्विड गैस डाली, इट इज़ गेटिंग कन्वर्टेड इनटू वेपर्स. तो वेपर्स को आपने वापस शोर ट्रांसफ़र कर दिया, शोर भेज दिया, या अपने प्लांट में उसको करके वापस यू आर इंट्रोड्यूस. तो एक स्टेज आएगी कि जब स्लोली आपका टैंक ठंडा हो गया. वंस द टैंक बिकम्स कूल्ड इनफ, सपोज उस टेम्परेचर पे आ जाता है, तब क्या होगा, जैसे ही टैंक आपका ठंडा होगा, देन यू सी until the boil of ceases. अब ये जो लिक्विड गैस है ये वेपोराइज होनी बंद हो जाएगी. तो कूल डाउन शुड कंटिन्यू until the boil of ceases and liquid becomes to form in the bottom of the tank. अब जो आप लिक्विड डाल रहे हो, बिकॉज अब टैंक आपका उसी टेम्परेचर पे आ गया, नो मोर वेपोराइजेशन, नो मोर बॉयल ऑफ. जैसे आप लिक्विड करोगे, वो आपके टैंक में लिक्विड जो है लिक्विड ही रहना शुरू हो जाएगा. सो दिस कैन बी सीन फ्रॉम द टेम्परेचर सेंसर्स थ्रू आउट द कूल डाउन. Deep well pump shaft should be turned frequently by hand to prevent pumps from freezing. And ये अब ठंडा जो लिक्विड है, whatever at -100, -70, -80 जितने पे भी है, अब ये लिक्विड जो है बनना शुरू हो जाएगा. सो फ्रॉम द सेंसर्स टू नॉलेजिंग का जो सिस्टम है, जैसे आपको टैंक में लेवल दिखाना शुरू करेगा, टैंक लेवल गेजेज जिस टाइप की भी हैं, सो देन यू कम टू नो. एंड फ्रॉम द टेम्परेचर सेंसर्स की टैंक इज कूल डाउन एंड नाउ the liquid is remaining as liquid, no more vaporizing. So once the cargo tanks have been cooled down, cargo pipeline equipment should be cooled down, and फिर आपकी you are ready for loading. So before loading operations begin, the pre-operational, ये तो था आपका यहाँ तक cargo operation का sequence. So this is very brief to the point. तो भाई ये operation हमने करने हैं. Of course, करने के लिए there is nothing. Once you go on the ships as a third officer, second officer, so you start learning, you start seeing the things, यहाँ भी क्या चीज़ कैसे करते हैं, and then finally जैसे आप चीफ ऑफिसर बनोगे, so slowly हर ऑपरेशन बंदा सीख जाता है. ठीक है, I hope clear up to here the cargo operation sequence to everyone. Any doubts, any questions? क्या कहते हैं?
क्लियर सर.
चलो, आई होप यू शुड बी एबल टू आंसर. तो इसको थोड़ा सा प्रैक्टिस कीजिए बोलने की भी. यहाँ टैंकर्स हैं, उसका क्या प्रोसीजर होता है, जैसे आपको बताया, वी हैव सीन इनर्टिंग क्या होती है, गैस स्प्रिंग क्या होती है. बट अगर आप उसको थोड़ा सा स्पीक बोलोगे तो आपको भी पता लगता है, हाँ यार मेरे को आता तो सब कुछ है, बट जब बोलने की या लिखने की बारी आई तब ये बात बनती नहीं. ओके, सो ट्राई टू डू आप अमंग योर सेल्फ, एक दूसरे से पूछेगा, अच्छा है तुम बताओ जरा इसका सीक्वेंस क्या होता है, अच्छा टैंकर आएगा. सो दिस इज़ हाउ यू बेसिकली स्टार्ट लर्निंग प्रैक्टिस. आप अपने आप ही अपने साथ ही बात करोगे तब नहीं बात बनती, या फिर पेपर पे लिखना शुरू कीजिए, चाहे आता भी है पॉइंट्स वाइज के. ओके, दिस 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 दिस. सो दीज आर द बेसिकली द कार्गो सीक्वेंस ऑपरेशन. यहाँ जी ठीक है, आपने टैंकर केमिकल गैस कैरियर नहीं भी किया, कुछ नहीं होता, जब जाएंगे सीख लेंगे, बट थ्योरी तो आपको थोड़ी पता होनी चाहिए कि हाँ यार गैसेज होते क्या, डेंजर्स क्या है, कैसे हमने करना है। चलो टेक अ ब्रेक, हैव अ कप ऑफ टी, वी मीट, ठीक है 10-15 मिलते हैं वापस, ओके
Okay,
Yes,
sir.
sir.
Thank you, sir.
Thank you.
ओके।